Question 7 of exercise 5b, it says, for each of the following, 2 of the 3 expressions are equivalent. State the odd one out. Okay, so 2 of the 3 expressions are equivalent. So what does that mean again? So equivalent means that they would give you the same answer. They would give you the same answer for every value of x. Okay, so say if I put x equal to 1 in, okay, all of these would give me a certain value, and the 2 that give me the same values, they are equivalents. Okay, now we do have to test a few values for x, okay, because they may be the same for one value of x, but they may be different for another value of x. Okay, so what I'm going to do, I'm going to show you, so this is my way of answering this question. So I'm going to make a table. Okay, so I'm going to have x at the top here, then the first expression we have is 4x, the second is 3 plus x, and the last is 3x plus x. Okay, and what I'm going to do is I'm going to use a few values. Okay, so I want to, okay, I've got 0, 1, 2, and I try -1 and -2 as well. Okay, so remember we want to test a few values of x. So if they all, so when we substitute these values of x into these expressions, if, say for example, now I don't know which one are equivalent at the moment, but let's say this row for 4x and this row for 3 plus x, if they are all the same, then these two are equivalent. Okay, or if the first one and the third is all the same, then these two are equivalent. Okay, and so on. So now the easiest one for me to try out is 0. Okay, x equal to 0. So 4x is 4 times x. So 4 times 0. 4 times 0, anything multiplied by 0 is 0. Second one here is 3 plus x. So 3 plus 0. 3 plus 0 is 3. So we know right away that these two are not equivalent. So that means that must be the 4x and the 3x plus x. But I'm going to try this out as well. So 3x plus x. So 3 times 0, that's 0, plus 0 is also 0. Okay, so they these two would be the equivalent. Okay, now because we know that 2 of these expressions are equivalent, so we know that these two, 4x and 3x plus x, must be equivalent. Now, if the question did not say that, then we would have to try out all the values here. Okay, I'm going to do that just to show you guys. Okay, so next one is x equal to 1. So 4 times 1 is 4. Now, I'm not going to do this one because I know that that is not equivalent already. And then 3x, so 3 times 1, that's 3, plus 1, that's 4. Right. X equal to -1, 4 times -1 is -4. 3 times -1 is -3, plus -1, so they're getting more negative, so -4 as well. Okay. And 4 times 2 is 8. 3 times 2 is 6, plus 2 is 8. And for -2, 4 times -2 is -8. 3 times -2 is -6, plus -2, that is also -8. So we can see here the first and the third expressions, they are equivalent to each other. Okay, for B, we do the same thing, but this time with the letter A. So we have 2 minus A, and A minus 2, and A plus 1 minus 3. Now, you probably can already guess which one will be equivalent by um, simplification. Okay, we are going to learn about simplification later, but if you already know about that process, of course you can work this out already. Okay, but I'm just doing this just in case you don't know that process. So again, we have all the values for A from -2 to 2. Okay, now we're only testing 5 values here. Of course, you can also try more values, okay, but it should give you the same answer. All right, so starting with 0 first, that's easy to work out. So 2 minus A, so 2 minus 0 is 2. A minus 2, 0 minus 2 is -2. So right away, we know that the first and the second are not equivalent. Okay, now the last one here, we've got A plus 1 minus 3. So we have 0 plus 1. Well, that's 1. 1 minus 3 is -2. Okay, so that means the second and the third expressions are equivalent to each other. And I should do the same for this one as well. So for A, the first and the third are equivalent. Okay. All right, now let's do C next. So C, we've got T as a letter. We've got the expression 5t minus 2t. Then 2t plus t. And 4t minus 2t. Okay. Now you probably see from A and B is that a lot of time, just by substituting, just one number is enough to show whether two expressions are equivalent or not. Okay. And I must say we were quite lucky with those. Let's see if we're still lucky with this one. Okay, so let's try 0 out. Unlike 0, 0 is a very nice and easy number to work with. Okay, so 5 times 0, okay, 5t, so 5 times 0, minus 2 times 0. So 5 times 0 is 0, minus 2 times 0, which is also 0. So 0 minus 0 is 0. 2 times 0 is 0, plus 0, that's also 0. Now you may think, oh, so the first two must be the same, must be equivalent, but we should try the third one as well. So 4 times 0, that's 0, minus 2 times 0. So 2 times 0 is 0. So here we have got 0 minus 0, which also is 0. Okay, so here what you can see is that we need to test out a few more values for t. So let's try 1, because 1 is the next easy number to work with. So 5 times 1 is 5, minus 2 times 1, 2 times 1 is 2. 5 minus 2 is 3. 2 times 1 is 2, plus 1 is 3. Okay, maybe the first two. 4 times 1 is 4 minus 2 times 1. That's 2. 4 minus 2 is 2. So here, the first and the second one are equivalent. So you can see here that sometimes we need to test out multiple values for t before we can say that, hey, these two expressions are equivalent or not. Okay, last one, we've got D, we've got the letter U. So 8u minus 3, 3u minus 8, and 3u minus 3 plus 5u. Okay, just like the other ones, we are going to start with 0. Let's try it out. So 8u, so 8 times u, 8 times 0, that's 0, minus 3. 0 minus 3 is negative 3. 3 times 0 is 0, minus 8 is negative 8. Yep, these two are definitely not equivalent. 3 times 0 is 0, minus 3, this gives you negative 3, plus 5 times 0, 5 times 0 is 0, negative 3 plus 0 is negative 3. So the first and the third are equivalent. So you can see here, these questions, the whole idea is you just have to substitute in a few values, usually 0, and you can work out which one would give you the same answer. And if two expressions give you the same answer for multiple values, then they are equivalent. Okay? I hope this helps you with question 7.